This is my week 2 weekly summary. Start off with the Tinkercad. So, when I started first messing around with Tinkercad, it seemed to me like a pretty rudimentary SolidWorks, and once I got a little bit more comfortable with it, I started to want to see what I could do with it, kind of push the boundaries a little bit. And my neat resource was a video I found of a maker lab in Utah that posted a video on a little bit more advanced features that you can do with Tinkercad in order to create some more advanced parts and such. There were 2 other resources that I found that were super helpful. Jennifer Cordova had an Instructables website on how to use Tinkercad, and I found this one super interesting because I've always found Instructables pretty helpful and pretty dummy-proof. And it also has basically a step-by-step on how to start using it rather than just what you can do with it. So I thought that was pretty cool. The other one was Gabriel Wahlberg. He had a Tinkercad tutorial site, and this one is pretty self-explanatory. Usually if a company has a product, their own instructions and tutorials usually are pretty dang good at getting you started, and this does just that. You can do the 3D modeling. It teaches you how to do program simulations, creating a design, running codes, all sorts of fun stuff. So I thought that was another really good, neat resource. For the 2 discussions for the week, we had Math and Real Engineering. All of my research kind of led to one thing, and it's that most of what we're doing in terms of engineering-based math is going to be used depending on, depending on what field you go into. So if you go into what my video, what this gentleman in my video that I found does, he was analyzing the error in a satellite because satellite surfaces aren't perfectly smooth, so they're going to have some sort of margin of error. Now he was bringing up ideas from Calc 3 with using matrices and a little bit of partial derivatives and stuff with MATLAB, but everything he said was already quasi-coded in MATLAB. He just had to go through the program, perfect it, and figure out how to use it a little bit better. So it seems the first few years, maybe if you're working for an already established firm, they're already going to have a somewhat generalized idea of what you're already going to be doing, so you just need to be able to recognize concepts and be able to apply them rather than actually working out specific problems. The Nature of Science article was really interesting to me. I hadn't ever tried to push the boundaries in terms of what people thought of science or what the perceived idea of the definition or idea of science is. For me, I look at everything logically and analytically. So I think that his main few points is that theories, hypotheses, and laws can only be disproven, not proven. I kind of sort of agree with that, kind of sort of disagree with that. My main points in my reply, in my discussion, was that the 3 of those, or any of the conjunctures of science, if you will, are put into bins or categories. And I think that each bin or category has its own ratio of proven evidence, right? So if an idea, if a theory, a hypothesis, a law is proven 8 times and it's disproven once, then it's running a 8 out of 9 ratio, which is a pretty high percentage. Now, whatever bin that gets put in, that's way above my pay grade. But I can say, for my opinion, I think hypotheses are probably between the maybe 20 to 60 percentile of proven evidence. Theories are between probably 60 and 90 to 95, and then theories are laws, are probably 99 plus, because the scientific community takes laws to be true, so there has to be a great deal of evidence backing them, with minimal to almost no evidence disproving based on technology. Moving on, we looked at some basic Excel stuff. I've had a couple classes that have run me through a bunch of Excel things, so going over these 2 documents were just refreshers. I've done basic to moderately difficult functions with Excel, so I consider myself amateurly well versed. The Logger Pro tutorial. I haven't ever used Logger Pro, so the fact that Logger Pro comes with tutorials is really helpful for me. For this one, I got it done pretty quick. It wasn't too difficult. The instructions lays it out so well. It's descriptive, and I got pretty dang close. It said my magnitude of coefficient for time squared should be close to 4.9. Mine was 4.910, which I think is pretty dang close if I'm off by 100th or 10th. In terms of all of the I'm blanking on what these are called. These guys here. They are the coefficients for the quadratic formula, the correlation, and the RMSE. The A is the coefficient for the first figure, and it's the acceleration. B is the velocity of the particle, and C is going to be the position of the particle, all with respect to time. The correlation is how close the quadratic fits the points, and the RSME, the root, what was it? Root something squared something. I wrote it down. It was the there it is. Root mean square parameters. That's what I was looking for. Root mean square error. That's going to relate to the goodness of the fit. This is a screenshot of what you just saw from... No, it's not. My screenshot's right here. Also right here. But yeah, the Logger Pro, it seems like it's going to be a pretty simple program to use. My only concern with this is going to be taking videos similar to this one in the future with maybe a newer phone or maybe even a nice camera. It's going to have a lot more frames, so it's going to be a lot more data plotting, which is going to get you a better correlation and a better RMSE, but it's going to be a lot more time consuming and tedious. For the instructables, I found a website on how to create a 3D printed phone case. I talked a little bit when I posted it to the discussion board that I think phone cases are super underrated. Everybody uses their phone every single day, and some people use their phone case as a kickstand, for example. Some people use it as a fashion statement. Some people just use it simply for the functionality of protecting their cell phone. I think it would be kind of cool and kind of be a little self-boast to be able to make one and say, I made this. It has my name on it. It's got my design in it. I think that would be really cool. Two other Instructables with the 3D printed category is the elbow flip switch. Andrew Oxley posted this one. Super interesting. Kind of basic, never thought of it myself. I guess that's why engineers exist, right? And the other one was Justin Barr had a design for a 3D printed speaker on his Instructables. This is cool. I've made speakers out of some weird stuff like gas cans and suitcases and stuff like that. I've never thought of printing one, so I might have to give this a try. Thanks for the idea, Justin. In terms of real-life application, this class has kind of pushed me to think a little bit outside of just my school. I use SolidWorks professionally for a couple different companies because I do have my associates and my professional certificate in it. So playing with the Tinkercad, it's definitely a new way of looking at 3D printing and 3D modeling, and looking at the different ideas that you can do with 3D printing. It's always fun to me to be able to think of a new idea or see something and want to make it, because as my grandfather always said, why can you buy it for $50 when you could make it for $200? Just food for thought. The last thing I'm going to touch on right now for this week is our team. I'm teaming up with a gentleman by the name of Sean Sullivan. First name Eric, he goes by Sean. We're the Matt and Sean Show. That's our team name. I've worked with him a lot. He goes to NAU up in Flagstaff with me. Where is he? There he is. I've worked with him on a couple different projects. I'm actually working with a project. I'm working on a project with him this semester outside of this class for another class as well. We have similar learning styles. We know how to communicate with each other effectively. It's a super beneficial relationship in terms of kind of pushing each other, because we're kind of on the same track in terms of our classes. So we're kind of keeping up on each other in terms of how we're doing. So it's going to be a pretty good professional relationship with him, already having known him and knowing how he works and him knowing how I work. Yeah, we're the Matt and Sean Show. So we're both kind of excited to see how this class goes, see how these projects go, and hopefully get ourselves a pretty good grade on it. This was my weekly summary for week 2, and I will call it here at 14 minutes.